So I'll start the recording. So just a reminder that 5.2 and 5.3 are due today. 5.4 is due on Saturday, and then you have that third review that we'll talk about tomorrow. That's due to my Gmail account again. And then Sunday you've got quiz 6, and then that initial post on the M3 discussion is due. And don't forget that at any point in time you can start scheduling your next exam with ProctorU. But what I want to do is a go backwards problem from yesterday, which I forgot to do. We just didn't get there. So this is out of section 5.3. You're going to have 2 of these at the end of the homework for that section. So we want to find a rational function that might have the given graph. So my graph has a vertical asymptote at -1 and another vertical asymptote at +1. There's a horizontal asymptote sitting on top of the x-axis. That would be y equal to 0. And then we can see that all we have as far as points go is 1 point right smack at the origin. And what we want to do is recreate the function that would give me this picture. So what we're going to do is write something, and then we're going to check it on the calculator, because that's just the easiest way to do it. Okay, so we know that the vertical asymptotes make up the denominator. So when I go to write my denominator of my function, I'm going to pick up the -1 and the +1. The x equals -1 would come from a factor of x plus 1, and the x equals 1 would come from a factor of x minus 1. And that's where the vertical asymptotes come from. So far, so good. The next thing I'm going to do is pick up my x-intercept. It comes from the numerator. Because this x-intercept is at the origin, it would be an x minus 0. I don't really need the 0, but that way you can see where it's coming from. And because the graph is crossing there, I know that's going to be to the first power. And I'll clean this up in just a minute. Okay, so right now, what I think we have as a function is just an x in the numerator over an x plus 1 times an x minus 1. Okay, now we accounted for the vertical asymptote, check. We counted for the x-intercept, yes, check. So now we're going to come in and check to make sure the y-intercept falls where we think it should be. So if I come in and replace all my x's with a 0, then I end up with 0 over -1, which is 0. So the y-intercept works also, so that picks up that origin again. What about the horizontal asymptote? Well, the horizontal asymptote for us is y equal to 0. So anytime it's the x-axis, I know that it has to be a bottom-heavy function. Again, that means the degree in the denominator is larger than the degree in the numerator. Well, if I FOIL this out, we can see we have x squared minus 1 in the denominator, so it's bottom-heavy. So far, everything checks beautifully. But of course, it can't be quite that simple. So what happens if you go to graph that function on your calculator, you're going to see that the whole thing has been reflected. So it appears over down here in quadrant 3. The S in the middle starts above and ends below. And on the right side, it's over here in quadrant 1. So the whole thing's been reflected. You could check this without a calculator by just picking a value like 2. So if we plug in 2, so if we let x equal 2 and plug it in, if we find r of 2, we'd get 2 over 2 squared minus 1, that's 2 over 3. I get a 2/3. So at 2, it should be above, and it's not, it's below. So that's the other thing that's telling me the whole thing's been reflected. So what I'm going to do is just put a negative out in front. So I'm going to make the whole thing a negative. That does a reflection like we think it should, and then it works out perfectly. So again, you're going to have 2. They're going to give you a picture and ask you to recreate the functions. So the vertical asymptote gives you your denominator. The x-intercept gives you your numerator, and then you need to check to make sure that your y-intercept and your horizontal asymptote are where they belong. The other thing to comment really quick before we move into the next section is the book does not draw the horizontal asymptote in if it's on top of the axis. What they're going to do instead is you'll see the axis. It's kind of hard to erase it here. You'll see the axis, and then on the ends of the axis, you'll see dotted lines. So they'll put a dotted line on each end, and that's telling you that there's an asymptote there. I don't care for that myself because I think it's kind of hidden, but that's how they'll do it. Okay, and that does wrap up section 5.3. So any question on just finding a function if you're given, given the picture?
So what accounts for the, because isn't the S shape that we see between -1 and 1 an x to the third?
Well, no, it's just a crossing is what it is here. So remember that that's the multiplicity in the numerator, and we just know that it's going to cross.
Okay.
So all it's telling me that is crossing. I agree that it's an x cubed, but that's if it didn't have this other x stuff in the denominator. So
Okay.
we could check this by also plugging in like 1/2 and -1/2 into this function. And if you do that, you'll see that you get the correct stuff. So,
Okay.
okay. Okay. Moving on then. Any other comments or questions? No. The reason I like these go backwards problems, as I call them, because I know that you've truly understood something if you go the opposite direction on the thought process. So that's why I tend to pick them. So here we're going to move into section 5.4, which is a nice section for us. It's a nice quick one, but it does have some important concepts that you'll need in your future classes. So section 5.4, and this does end chapter 5 for us. So as of today, we're done with chapter 5. We only have one more chapter to go, but it's a long one. It'll take us the remaining, 4 weeks to get through it. So we're gonna do polynomial and rational inequalities. Okay. So polynomial and rational inequalities. Okay, so what we're going to do is the directions are going to look a lot different. They're just going to ask me to solve each inequality. And the first one we're going to tackle, so this is example 1. We're going to do x minus 1 times x minus 2 times x plus 3, and we want that to be less than 0. So it kind of looks like stuff we saw last week when we were doing stuff. It should look familiar. But all of a sudden we have an inequality. So what does that do for our problems? Well, it's going to introduce a whole bunch of layers to it. We're going to start off the same way we would have if I just asked you to graph this thing. So the first thing we're going to do is we're going to find the x-intercepts, which we're going to call in this section the boundary numbers, or critical values. They're the places where the graph is going to change signs. So that should make sense. If you think about those polynomial graphs that we had last week that were doing this kind of thing, right? At the x-intercepts is where stuff is changing from positives to negatives or negatives to positives. So that's why here they make sense in terms of needing them. Well, it's easy to do. You set each of the factors to 0. So we know that those boundary numbers are 1, +2, and -3. So 1, +2, and -3. Okay, now we're going to break off and do stuff that's different. So we're going to build a sign chart. And that sign chart is why we do this section in our class, because we need to be able to lay the foundation for future work. So our sign chart, and what you're going to do is you're going to build above and below this thing. So I need the number line. And on my number line, I'm going to place those critical values. So the -3, the +1, and the +2. So build a sign chart. So we're going to draw a number line. With the boundary numbers. The most common mistake I see here is that you don't put your boundary numbers in numerical order. You put them in the order that you found them in. Don't do that. Make sure they're in numerical order. Okay. The next thing we're going to do is we're going to write the factors. So the factors are the x minus 1, the x minus 2, and the x plus 3. And I'm going to place those above it. Now what I actually need is I need a row in through here. And then I'm going to list those factors. And the order you list them in doesn't matter. So there's the x minus 1. Then I'll have my x minus 2. And then I'll have my x plus 3. I didn't leave myself a lot of room. And then at the very, very top, I'm going to write the word test. And that's going to be the number we're going to test. So we've done is kind of taken that number line and divided it up into regions. And the regions we have are to the left of -3, between -3 and 1, between 1 and 2, and then to the right of +2. And those are the regions we have. And for the first one, we'll do the full-blown, completely filled-in sign chart. But at some point, you can start to take some shortcuts because your logic will fall in. So. And then what we're going to do is test each region. So that means we're going to pick a number that's in that region. We're going to plug it into those factors and see what kind of signs they have. So we need a number that's to the left of -3. I'm going to pick -4. And all I'm going to do is take that -4 and plug it into each of the factors for the x value. So -4 plus 3 is a negative number. I don't actually care about the value. All I care about is its sign. That's why they're called sign charts. I need its sign to determine whether or not this polynomial is above or below the axis. So that's all we care about is the sign. It's a little hard for us to get over that, but it works. Then I'm going to plug the -4 into that next factor. So -4 minus 2 is a -6. That's still a negative. -4 minus 1 is a -5. It's still negative. So no matter what number I plug in to the left of -3, all three factors are going to be negative. Okay, well, don't forget those three factors are multiplied together. So we're going to multiply a negative times a negative times a negative, and then the result is a negative. So when I multiply those three numbers together, no matter what numbers they are, I'm going to get a negative. Okay, well, you're saying, I don't know where this is headed. Just have some patience. So now we're going to pick a number between -3 and +1. So a good number to pick is 0 because it's between those two. So again, I'm picking a number that falls in that region of space on the number line. So plugging in the 0. 0 plus 3 is a positive. 0 minus 2 is a negative. And 0 minus 1 is a negative. Well, let's multiply those together and see what happens. So a positive times a negative times a negative. Well, the two negatives together give me a positive, and a positive times a positive is a positive. So what we've just established is that the sign of the polynomial is changing as it crosses at -3. We knew that because its multiplicity is odd, which the graph is telling me the graph should cross. So no matter where it starts, it's going to cross there. Okay, let's pick a number between 1 and 2. I'm going to use 1.5. I don't like to use decimals very often, but they work well here. 1.5 plus 3 is a positive. 1.5 minus 2 is a negative. 1.5 minus 1, though, is a positive. So again, I'm simply plugging in the 1.5 into each of my factors to figure out what kind of sign the answer will have. Well, if you multiply a positive times a negative times a positive, you're going to end up with a negative number. So in that region, the graph is crossed at 1 and is down in the negatives. Okay, then we'll pick something larger than 2, like a 3. So 3 plus 3 is positive, 3 minus 2 is positive, and 3 minus 1 is positive. So the net result there is a positive. Okay, and that's your sign chart. Very useful in your calculus classes. You'll use the idea of a sign chart there again. Now what do we do with it? Okay, so that was step 3. Step 2. Step 3 then is we're going to identify the regions that satisfy the inequality. Okay, so we're going to identify the regions that satisfy the inequality. Okay, what does that mean? Well, I'm going to go back to the original inequality, and I'm going to notice that it's a less than. So I need the regions that are less than 0. So because it's less than 0, we're going to pick the results that were negative, because we need numbers that are less than 0. So we're going to come back into that sign chart and look for the resulting lines that were negative. So for us, that's this region to the left of -3 and the region that's between 1 and 2. So once I've done that, we can then write the answer. Using interval notation. Okay, so the correct answers are going to be from to the left of -3 to -3. So that would be negative infinity to -3. And then we're going to go from 1 to 2. Now I'm going to use parentheses on everything because the inequality does not include the equal sign. So then my final answer then is negative infinity to -3 union 1 to 2. And that's your first polynomial inequality. Okay, now in hindsight, so after we've done all that work and it makes some sense, if we had written this just as f of x is equal to this polynomial, we would have come in and graphed it knowing that it crosses the axis of each of these. It's a third degree polynomial function, which means it starts below. And because the multiplicity for all those guys are odd, we know that it's crossing at each of those x-intercepts. So you'll notice that this mimics that. We know it's negative or below to the left of 3. We know it's above between -3 and 1. We know it's below between 1 and 2, and then it's above when you get larger than 2. So you can see how it ties into the polynomial graphing that we did in 5.1. But the idea of the sign chart is kind of important for future work, so that's why we like to at least do one of them so we can see them. Yeah. Any comments or questions? They should be fairly quick problems to do, but we got to work our way through. Let's do another one then. So example 2, I want to solve the inequality x minus 5 times x plus 2 quantity squared, and this time I want to be greater than or equal to 0. So the factor x minus 5 times the quantity x plus 2 squared is greater than or equal to 0. Okay, so the first thing we're going to do is identify our boundary numbers. That's our x-intercepts. Those are the places where the graph could change signs. So those numbers are going to be what, 5 and -2? Let's go ahead and build another sign chart just for practice. So we're going to list our factors. Our factors are x minus 5. I have x plus 2, but it's squared, and as I list it, I either need to list it twice, which makes no sense to me, or list it as a square. So that square is really important here. So make sure you include any outside exponents. Okay. So then I have the result, and I have the value that we're going to test. Okay. And then on my number line, I have -2, and a +5. Here's my sign chart. I did a better job of organizing it this time. So I have a test value, I have my 2 factors listed, and then I have the resulting line. Okay. Let's go ahead and plug a number in. So let's plug a number that's to the left of -2. Any number will work. So I'm going to use -5, -6, just to be different, just to show you can pick any number over there. So -6 minus 5 is a negative. -6 plus 2 is a negative, but I need to square it. So when I square it, it'll become a positive. And a negative times a positive is a negative. Okay, let's pick something between -2 and 0. I'm sorry, between -2 and 5, like 0. 0 minus 5 is a negative. 0 plus 2 is 2. 2 squared is positive. The net result is a negative. So the sign did not change here like it did in the first one, but we also know why. That's that multiplicity of that x plus 2 impacting things. So we can see at -2, which is coming a 0 from this factor, that at that x-intercept, the graph is staying on the same side because it's bouncing. So that's that multiplicity coming into play, which works because we know what it means. And I need something larger than 5. Let's use 10 because we know 10 is larger than 5. 10 minus 5 is positive. 10 plus 2 squared is positive, and the net result is a positive. Okay. So now that we've got our sign chart built, we'll come back in and pick the regions that satisfy the inequality. So this time it says greater than or equal to 0. So we're going to pick the positive region. We only have one of them, so it's this guy sitting here. So that means that we're going to go from 5 to infinity. And because of the inequality this time, we'll put a bracket on it. Now we have a slight issue that we have to address here, but any problem with that?
So do we have to find where, do we have to keep working our way back to a smaller number and find where at what? So let's say if 8, 8 also satisfies as a positive, do we have to go back? No.
No,
Pick one
no,
number
because
between.
once you've established a number over here gives you a positive region, anything bigger than 5 will work. So if we tried 6 or 7 or 8, no. So in other words, the sign of this graph changes at 5 and it stays positive all the way to infinity. So let's go back and think about it from graphing the polynomial point of view. So if we were to graph this polynomial, it's a third degree again. That's the 2 and the 1 on the outside coming to us. So we can come in and recognize that it's going to start below and end above again. But because of the multiplicity of the x plus 2 factor, we know the graph would come in and bounce at -2 and then head up like that. So we see the only region where it's positive is sitting over here. So again, you can do this either way. You can do it by building a sign chart, or you can go back and use your graphing analysis from the polynomials. Notice I'm not drawing a y-intercept in because it doesn't even impact it. What this is really asking me is where is the graph above the x-axis? So I just need to identify where it's positive. But I have an issue, and I'm hoping somebody recognizes what my issue is. It's that inequality having that equal to. This is asking me where the graph is greater than 0, but also equal to 0. So isn't it equal to 0 right here? Yeah, so I have to step back and think about what the inequality is saying. So I'm going to union this with just a single value of -2, because at -2, that graph is 0, which would satisfy that inequality. So to get the bigger picture, notice that you could check the answer. So in other words, you can pick anything that satisfies this answer, pick it and plug it in, and you'll get a true statement. So if I plug in a -2, I'm going to end up with 0 greater than or equal to 0, which is true. If I plug in a 5, I'll end up with 0 greater than or equal to 0. If I plug in a 6, I'm going to get some positive number that's greater than 0. So you can check the answers because we are back to solving things. Does that help?
Yeah.
Okay. Okay, let's do actually 2 more polynomials. And do you want to build a sign chart, or you want to look at it from the graphing point of view? Does the picture of the polynomial graph make more sense than the sign chart, or do you want to do the sign chart?
I like the graph.
Okay, let's go with the graph then.
Yeah.
We don't have to. Okay, so example 3. This time we're going to have 3x cubed is less than a -15x squared. Okay, so the problem with this one is it's not in factored form. All the others have been listed as factors so that we can pull those zeros and those x-intercepts off. This one's not in that form. So the very first thing we're going to do is move everything to one side. Oh, that's a cube. I said it, I just didn't write it. Okay, let's move everything to one side. So I have 3x cubed plus 15x squared is less than 0. And then we're going to factor it. So to factor it, what can I pull out of both factors?
3.
And an
About
x.
3x squared.
Yep. So that'll leave me with x plus 5 is less than 0. So the places or our boundary numbers, our x-intercepts, are going to be at what? -5, and then again at 0. So something's happening at -5 and something is happening at 0. Okay, we know that again, it was an x cubed. We know that x cubes start below and end above, as long as there's no negative stuff in them. So it's going to come in from below. It's going to hit that -5, and is it going to cross or bounce?
Cross.
Yep. And it's going to get pulled back down to the 0, and at the 0, it's going to do what?
Bounce.
Yep. So it looks like that. So that's a lot quicker than the sign chart. It really is. Just so you've seen a sign chart someplace, that's all we care about. Beautiful. Okay, let's answer the question. Where is this thing less than 0? So where is this picture below 0? to the left of -5?
-5 or negative infinity to -5.
Beautiful. And because of the inequality, we're going to put a parenthesis on that -5. So, yeah. So if we'd done the sign chart, we literally would have gotten a negative, positive, positive on those regions, which is telling me where the graph is. So, nice. Okay, one more, and then we'll move into the, I thought I had one more. Yeah, one more. Then we'll move into the rational inequalities. So number 4, we have x to the 4th is greater than or equal to 1. So x to the 4th greater than or equal to 1. Okay, so same issue. In order to do this analysis, we need to know where it's above and where it's below the x-axis. So we have to compare it to 0. So we're going to move the 1 over. At that point, I need to factor that. So we'll factor it as the difference of squares. So that would be x squared minus 1 and x squared plus 1 greater than or equal to 0. X squared minus 1 factors even further into x plus 1, x minus 1. The x squared plus 1 does not factor in the real number system. That would give me i's, which we saw at the end of last week. Because those are giving me i's, they don't impact the graph. I'm just going to ignore it. So I'm going to make a note to myself that this is a imaginary 0. Has no effect on the graph. So I can pretty much just ignore it. So that means that the only places where we're going to cross the x-axis are going to be at -1 and +1. So our graph, -1, +1. That's it. Okay, I got to figure out where this picture is going to start and where the picture is going to stop. Because it's an x to the 4th, it's a 4th degree polynomial. So that tells me it's going to start above and it's going to end above. And what is it doing at each of these x-intercepts? Well, what's their multiplicity, even or odd?
Odd.
So it's going to cross at both of them. So it would actually look like some kind of parabola, right? X squared plus 1's not impacting the picture. Nice. Any problem with that? And go back to the inequality then. So then what's our answer going to be? So where is this graph above? Because it says greater than or equal to. We need where it is above the x-axis. So it's above the x-axis from
1.
So what, -∞ to -1? And then again, and I think I just messed up, from 1 to infinity. Yeah, I did. The inequality's got an equal to on it, so I have to move those into brackets. So. Okay. Nice. Okay, now where you might see this problem in your future. So just to tie it into what you will need, you're probably not going to see something that's written like this. But what you might be asked is to find the domain of f of x equals the square root of x to the 4th minus 1. So at first glance, these look like really different problems. However, we know that because it's a radical and an even root, what you're going to do to find the domain is set the inside greater than or equal to 0. So you would set x to the 4th minus 1 greater than or equal to 0, and then you're doing this analysis. So that's where it ties in into your future. So anytime you have a radical and you have an inside exponent, you're going to have to go through this kind of analysis. So then to answer the question, the domain would go from -∞ to -1 and from 1 to infinity. So it helps us find domains of other types of functions, which is nice for us. Okay, does that tie into domain make sense?
Yes.
Woohoo! Okay, let's go do the rational inequalities then. So the other part of the section has these. This is example 5. We're going to slightly switch gears a little bit, it will look like. So we're going to do x plus 3 over x minus 1 greater than or equal to 0. So x plus 3 over x minus 1 greater than or equal to 0. Okay. So these are rational inequalities. And again, they're rational because you see x in the denominator. So that's what makes it a rational function. Your analysis here is basically the same thing again. The only thing now is you have to address the critical or boundary numbers that come from both the numerator and the denominator. So what we're going to do is we need to identify the x-intercepts and the vertical asymptotes. Because those are the places where the signs are going to change. They're going to change at the x-intercept, and then they might change again at the vertical asymptotes. So for us, we know, and again, I'm only going to draw the x-axis. We know that something's going to happen at -3, that's an x-intercept, and something's going to happen at +1, that's a vertical asymptote. So because I tend to make a little sloppy error here, I'm going to label that one as the vertical asymptote, and I'm going to label the -3 as the x-intercept, okay? So what that's telling me is that, again, the graph cannot cross or touch that vertical asymptote. So I'm just labeling them like we would have done yesterday. Okie dokie. Notice we don't have near as much information here. We don't know about the end behavior, so we kind of have to test what's going on. So instead of building the full-blown sign chart, we're just going to get a handle on the first region. So what I want to do is just test this left region. That's it. Only that left region. So we're going to test by letting x equal what? -4? And you can pretty much verbally walk this through. If you put a -4 in the numerator, you're going to get -4 plus 3. That's a negative. If you put -4 into the denominator, won't you get another negative? And what's a negative divided by a negative?
Positive.
Yep. So we know that in this region, we're going to get a positive. Okay, now we're going to use that wonderful idea of the fact that every time we found something yesterday in our graphing, that the signs change. So if you think about what's going on here, we've got this asymptote sitting here. This is an intercept. The graph is coming in and doing this to head towards that intercept. So we know it's going to be negative over here. And because it's negative on this side, isn't it going to be above on this side because they were in opposite regions? So that's that multiplicity on the asymptote coming back into us again. I hope I'm not skipping too much. I'm hoping I'm getting what we need across without having to do a lot of work to it, because all the work we've already done in the chapter pays off. So if we were to graph the actual function, we'd see something like this going on. So we know it's above, then it goes below, and then it's back above. So, sorry. Well, now we have to go address the actual inequality. The inequality says we need to pick where it's above. So, where is the graph above the x-axis? And that's what it's asking us. So this graph is above the x-axis over here, and then again over here. So we're going to go from -infinity to -3 with a bracket. And then we're going to go from, and I'm going to make a mistake here on purpose, 1 to infinity. So the bracket is coming off that inequality, but that 1 is a vertical asymptote. And you cannot plug the value of a vertical asymptote into the function, because if you plug in 1, this blows up and you have problems about dividing by 0. So we will never be able to bracket in the vertical asymptote. We will always have to use a parenthesis there. So even though the inequality says to include it, the division by 0 rule says don't include it. So that's our answer then. So we're going to go from -infinity to -3, including -3, and 1 to infinity. So again, you can check this. You can pick any number that falls in these two regions, plug it in, and you'll get a true statement. So in other words, if I plug in, I don't know, 4, right? If I plug in 4, I'd get 7 on top over 3 on the bottom. 7/3 is greater than or equal to 0. So you can check them, which is nice. Okay, does that make sense in terms of a number line sign chart or a graph sign chart, I guess?
Yes.
Yeah, it'll make a lot more sense once you do the homework from 5-3. So we're gonna do one more of those. So our last example. So example 6. We're going to do x minus 1 all over the quantity x plus 2 and x minus 3, and we want to be less than 0 this time. So x plus 2 and x minus 3 in the denominator. So we need to pick up all the places where we can have issues with our signs. So the x-intercept from the numerator is a 1. The vertical asymptotes from the denominator are at -2 and +3. So I need to get them in numerical order on my graph. That's the main thing. If you don't put them in numerical order, all kinds of goofy stuff happens. Okay, so I have a -2. I have a +1 and a +3, and those are my critical values or boundary numbers where the sign of the function changes. Okay, I'm going to mark my vertical asymptotes in. So this is a vertical asymptote, this is a vertical asymptote. So again, those are dotted lines. The graph cannot cross. The x-intercept was at 1. We know the graph can cross. But again, that's not enough. I need the end behavior. So I'm just going to pick a value that's on the left region and then let the graph dictate from there. So I just need to test over here. So let's test -4. Anything to the left of -2. So we're going to test a -4. You just need to plug it in. That's going to drive me crazy. I got to write my x-intercept as a point. Sorry. Okay, plugging a -4 in. So if I plug in a -4, I have -4 minus 1 in the numerator. In the denominator, I have -4 plus 2 and -4 minus 3. Okay. Well, -4 minus 1 is a -5. -4 plus 2 is a -2. -4 minus 3 is a -7. And again, I don't really care about the value. I just need its sign. So I have a negative, a negative, and a negative. Well, 3 negatives make that answer a negative. So that tells me the graph is down here. So in this region, the graph is below. So it's below the picture. And the minute I know that, I know everything else that's going on. You say, wait, how can we know that? Because we know we have to alternate the signs, right? Because there's no multiplicity where anything is bouncing or we have repeats. We know we can alternate. So if it's below over here, it's going to be above over here. It'll go to below, and then it'll be above over here. So again, in this region, it's negative. In this region, it's positive, negative, and positive. So instead of doing the whole blown sign chart where you would list all 3 factors, we can just test one region and go from there. Okay, any comments or questions about that?
I'm okay.
Great, wonderful. Okay, let's answer the question then. So the inequality up here says we need to pick the negative regions. So we need to pick where the graph is below the x-axis. That's that less than coming into play. So our answer then is going to be from -∞ to -2. I'm going to use parentheses because the inequality doesn't have a bracket. And then the other place where this is below is from 1 to 3. So, and that's our answer. So again, where you will see them in the future is they're going to come in and ask you to find the domain. They're going to hide it inside a radical. So they might do x minus 1 over x squared minus x minus 6. So I just FOILed that out really quickly. So they're going to ask you to find the domain of this. So what you do is you take that inside, you set it greater than or equal to 0, right? So you would take the x minus 1 over x squared minus x minus 6 greater than or equal to 0, and then solve it. So we can let our previous work for us. So the sign chart over here is not going to change. That graph is not changing whether we're in a radical or not. So in terms of what's going on with this statement, we need to pick the positive regions. So then our domain would be the positive regions, which were from -2 to 1. And from 3 to infinity. Notice we're picking the opposite regions because the inequality switched. So, whoops. Sorry, that was my fault. I need brackets, but the only place I can put a bracket is on the 3. The other two numbers are coming from the asymptotes, and you cannot bracket them in. So you're going to do several polynomials. They'll come in and do, I think it's like 2 of the rational functions. And then you have 2 domain questions at the very, very end. And that's just to tie what you're doing in this section with the rest of the class. So and that's what's in section 5.4. It's fairly quick as long as you can grasp the graphing nature of everything that we're doing. So any comments or questions?
Okay.
And I'm really excited because that gets us through chapter 5 and only 1 chapter left, chapter 6. It's a beefy chapter, but only 1 chapter to go. So, okay, any comments, thoughts, words? Just the 2 of you? Yeah, I don't know. Well, Adam texted me and let me know they were having internet problems. So I heard from him. I don't know where Matt is. So, okay, well, have a great day and we'll see you tomorrow. We'll talk about the R3 review. If you get the chance before tomorrow, try and get it printed. Or at least looked at, because I have some specific problems I want to walk through, but if there's anything else on there that looks kind of fishy that you don't remember how to do, I want to address those. So, okay?
All right.
Have a great day. Enjoy it.
You too.
Thank you.
Bye-bye.